Hi everyone, my name is Alex. I work at Opper. We are an AI engineering platform that we started around 6 months ago. I'm not going to talk too much more about this, and I'm going to go straight into the topic, and we'll see a bit about Opper during the presentation. So today we're going to talk about agents. So not this type of agent, not yet at least. We're going to talk about software AI agents that you've probably heard of a lot during the last year, I guess. But there's not been too much concrete stuff coming out. A lot of hype, a lot of things, but not too many real products. So I think today we're going to talk a little bit about first this little history behind this. Then we're going to look a bit at agents, what they are. Then we look at what methods we have to increase their accuracy and why they're probably going to start working more and more. And then we look at some specific patterns you can implement when you have agents, and then some conclusions. All right, let's go. So a bit of history first. So I kind of arbitrarily started this timeline at the Transformers paper, but there's lots of stuff that's been happening before. Language models are not new at all. It's been existing forever. I was writing LSTMs to write on forums like 15 years ago, more something like that. But it just didn't work very well at the time. It was mostly outputting gibberish. But things have been getting better and better, and we've kind of found out that scaling helps a lot, and that's been enabled by a lot of things, but transformers are one of these things that enabled scaling. Then we discovered that you could do transfer learning. So because before we used to train networks to do one task, and then another network to do one task, etc., etc. And then we realized that, oh, we could kind of fine-tune a model to do this task and then that other task, etc. Then people started to fine-tune on not doing tasks, but doing instruction following. So kind of like taking one step up in the abstraction layer. And that's kind of what led to ultimately to InstructGPT. So that's when they OpenAI took GPT-3 and they tuned it for instruction following, and it started to work really, really well. And then they started tuning it for chat, so multiple turn instruction following. And that's how we got ChatGPT. But for developers, a bit before that, so after InstructGPT, the first APIs, I guess, for OpenAI were released. And that's when a lot of people started building with this, and lots of companies started to really think about building products around AI. So it worked a lot less well at the time, but that's when really it finally became available for regular developers, because before that, it was mostly in research papers. Yeah, so that's the quick summary of where we are. And so about a year and a half ago, we got ChatGPT, which I'm sure you all have tried, which is kind of an incredible piece of technology when you think about it. You can ask it stuff and it seems to understand mostly. So you can ask it to write an abstract for your talk, but I didn't use this one. But the problem is that these models really, they're really great, but when you start using them, you just want them to do stuff. If you truly want them to be an assistant, you want them to interact with the world. You just don't want them to be a text in, text out, black box. That's that the original ChatGPT was. So I have a bunch of questions here that I asked ChatGPT without internet connection, and so obviously it cannot do anything, cannot answer the questions about the current weather or something about the current events or something like that, or summarize my emails. So this stuff is coming, I know, but this isn't what we had a year ago. So developers quickly realized that it's only really useful if you can connect external data to these models. And then I guess there are a few patterns that kind of came out of this. But one of the common ones is called RAG, for Retrieval-Augmented Generation. So I'm going quite quick over this. I assume you've heard about this stuff. So this is the idea of building a prompt, so a message for an LLM, and adding some external information in there that is going to help to steer the model in the right direction. So in this case, I'm asking a question about football, about an upcoming game, and I got some relevant text from somewhere else. So in this case, the relevant text is kind of literally the answer, but in real life, it's often more a bunch of text that contains similarly rated stuff, but we have no idea what the real answer is. And so we stuff that into a prompt, and then we ask the model to kind of sort it out based on the information in the prompt. And so you've seen tons of products being built around this, which work more or less because hallucinations and a lot of problems. But that's RAG. And another paradigm that came is really giving the ability for a model to kind of literally use tools. And the only way to get that really to be done by an LLM through an API is to just tell the model, hey, you can use these tools, and it's up to you to decide how to call them. And when you want to call one, you just tell me by writing, following a specific syntax. So that's what people started doing, essentially adding a list of tools in front, and then having the assistant respond, okay, I want to use this tool. And then you would, as a developer, you could pass the answer back from a third-party API, and then the model would parse that response and just give you what you want. So that's called function or tool calling. And this has become a part of the API of many LLM providers. So it became kind of a first-class citizen that they have fine-tuned on. And it's a very common pattern now as well. Okay. All right, so agents, what are these things? They are programs that can autonomously take actions in order to reach a goal. So it's really, you give them a lot of tools and a goal, and they're going to try to figure it out, right? Let me wait. I feel like I'm missing a slide. Just let me double check something. Okay, no, it's fine. Okay, back to my slides. So agents, they can look like something like this. What's that? So you have a model, you have a bunch of tools next to it. So let's say you want to give your model access to your code base, so it can run code, it can write code. Why not connecting it to your HR system if people want to ask questions about that in your company? Connect it to your docs so it can find answers, manage some files. Why not calling the GitHub API, running some searches, etc. That's kind of the dream, right? You could go even further and think, okay, what if I tried to create the structure of many agents and I gave them some kind of personality by having one that is my developer agent that has access to developer related tools, and I had my product manager agent that's gonna write, it can do Slack stuff, Jira stuff, all the paperwork and the meetings or whatever. And this is kind of what happened, I guess, a year ago, when you saw a lot of new frameworks coming online, lots of GitHub repositories getting tons of stars or like retweets, like lots of hype, lots of these things came out. So you had, I don't know, BabyAGI, autoGPT, whatever. And these things were kind of about, like self-forking and having these big conversations between agents. And then you could make a nice demo on Twitter with lots of things talking to each other, and it looked super, super cool. And we got lots of demos at the time. So that came around the GPT-4 release. But the problem with these things is that it just doesn't work. Like, it just doesn't work. It makes for nice demos on Twitter, but there is quite a big path between a demo and a product. And the demo is the thing you do on the weekend, and then you think you could re-implement Twitter or Facebook or something in the weekend. And then there's a product that takes multiple years to build. So the state of agent really a year ago was that lots of people got these grand ideas about what you could do by simply giving access to an LLM to a lot of tools, but it just didn't work at all. And that's why these things kind of died out. I checked out one of the repos for, I don't remember if it's autoGPT or something, but it's dead. It has like 1,000 GitHub stars, but there's nothing. And I assume it's like this for a lot of these agentic things that came out a year ago. Because people, after the hype settled down, they realized like, hey, this doesn't work. Like, it's not impressive anymore to write a lot of stuff in the terminal. And why is that? Well, it's because errors compound. It's just, I think it's as simple as that. If you have an agent and you want to fulfill a task, and you need to do this, like let's say you have access to a bunch of tools, and it's going to take you 10 steps to get there. Like you need to do 10 actions. And assuming your probability of success of just one step is 95%, which is crazy high, so that's a very good case. It's only going to end up working 60% of the time in the end after 10 steps. And I took here a very good scenario where it works 95% of the time. In practice, it's often more, 80% or less. So you can see on this curve that you quickly go to levels where it's going to work 10%, 20%, 25% of the time. So then the question is like, what do you want to build with that? What products are you going to use that work 20% of the time? So these things don't really work because of compounding errors. And why are there errors? One thing is that language models struggle a lot with planning. Humans don't think of, oh, I have access to all these tools, I'm just going to take this one and then that one and then that one. Like, we implicitly create a plan before doing these things, even though we don't consciously think about it. And the language models don't think about anything unless they write it, basically. Also, a year and a half ago, we had very limited context in language models. So we had at the start, 2,000 tokens, then 4,000. Now we are at, okay, for GPT-4, we're at 128, and for Gemini, we're at 2 millions. So we can put more stuff about the history of what the agent has done now, but before we couldn't do that. So we had to really decide, okay, what am I going to put in the prompt for the next step? I need to be very careful about what I put there. Assuming this stuff works 100% of the time, are you willing to wait 5 minutes, 10 minutes, an hour for the thing you're asking to be done? It's unclear. It depends a lot on the use case. But for a lot of consumer products, or even just like enterprise products, you want things to be kind of snappy. And these agents have just been too slow to be very useful. On top of that, when you make a lot of LLM calls, it's very expensive if you want to use the frontier models. So that's also one reason you don't see too many agents out there. And then the last reason, I think, is that the field has been very immature about how to get the most out of language models, because we just got access to this new API. We can talk to it. I think we were very biased against chat, so we're gonna just talk a lot and do things, and we kind of forgot how to write software on the way. But it's not that negative. I think we can fix this, and the field is starting to fix this. There are many different techniques to try to improve accuracy. So let's talk about that. All right. So the first thing you should do when you start, I think, any project of any kind, is to be able to know when it works. Especially if you're a product manager or someone working on, or like an engineering manager or like a tech lead or whatever. When you start something, I think the first thing you think of is like, what's the criteria for success? What is the definition of done? And just how do I know that it works? And one thing that this field has struggled with a lot, I think, is that since we know that LLMs are kind of probabilistic to some extent, we basically kind of gave up and we're like, yeah, I'm just gonna try my computer, change my prompt, try again until it kind of works, and I'm gonna ship it. And the traditional software engineering field, I think, would tell you that this is terrible. We have learned to write unit tests for a reason. It's not because we think it's fun. Some people think it's fun. I don't think it's very fun, but we know it's because it's good. It's going to help us to catch regressions, etc. So we need to try to think, take a step back a bit and write tests as well. And before you start really trying to build an AI application for production, you should think about, okay, how am I going to measure that it works? How do I know that? And the answer so far in the AI field is called evaluations. So evaluations are just a way to run tests across, like a data set of examples, so 100, 1,000, 10,000, whatever, and then measure the accuracy of the model or the agent on specific task. And then you get a number out, which is your pass rate, essentially. So you get a 90% pass, 95% pass, etc. If you're able to define clearly how your program should work, or how your agent should work, and you can define how to measure that it works, you've basically already passed 90% of people trying to build applications, because most people are still just trying stuff out and shipping it because it seems to work, right? But this is not how this field is going to succeed, and this is why a lot of these frameworks have just failed. It's because there is no definition of that it works. So step one, take the time to think about how you're going to measure that it works. It's not always easy, because sometimes you have natural language coming out. So how do you measure that? There are lots of metrics that you can use in the context of RAG. So asking questions to a PDF or whatever database, etc. You can use some precision recall metrics. You can measure context similarity between your golden answer and your actual answer. you can get a lot of metrics around that. You can also try to do some exact matching in some cases. I think ultimately we're going to be writing unit tests like we have been doing before, because models are going to get better and better, so we can expect 100% accuracy. I kind of think like ultimately you should write unit tests, and if they don't always pass, then it means your product will not always work, and then you need to really think twice and ask yourself, do I want to ship this to my user? Again, it depends on your product. You can use LLMs to evaluate LLMs, so that stuff works surprisingly well. Almost, it's kind of it's pretty funny that it works. But you can ask GPT-4 to evaluate GPT-4, and so I pasted some screenshot here, for example, from Opper, where we gave a 40 out of 100 score to a function run by GPT-4 Turbo. So GPT-4 Turbo read the answer and thought that it was not very good. It thought that it was debatable whether the action was needed. And that comes from one of our Discord bots that is hanging out with us and being a bit annoying because it's answering too much. But so reflection works. Asking an LLM to rate an LLM works really well. And you can even ask an LLM to rate a lot of answers from a model over time. So you get a nice summary about what's going wrong, and you can get some kind of score. So there are always ways to measure performance of your application. Obviously, it's best when you can write unit tests and have some kind of exact pass or not. But if you cannot have that, you can always ask a language model, and that's a good indication of whether you're going in the right direction or not. All right, so success probability of one step. So going back to my previous graph of errors compounding, what we want is that we want to climb this ladder that you see here. We want to gain, accuracy percent points one by one, because after 10 actions, the effect of getting 1% accuracy are quite huge. You can gain 10% global accuracy on your task. So you really want to optimize each of these steps as much as possible. So how are we going to climb up this ladder? Well, I think you could just wait for a better model. And that's both, I think that is both the very naive answer and both the right answer at the same time, because ultimately the language models are going to push everything from the bottom up by just getting better and better. And we saw that this week with GPT-4o, I'll talk about later. So some people are building companies now and they get lots of funding, and you might think this is ridiculous, like this stuff doesn't work. But they are betting quite a lot on the models beneath them to get better, and they're gonna get the effects from this. And by doing clever engineering, they're gonna get exponential effect from this. And then when things start to work, then they'll fulfill the promise. So it's a bit a bet on the field to not hit the wall. But so far, it seems to be the right bet. But we don't know, right? So then you have the answer in between to do prompt engineering and optimizations. And so this is not the wrong answer. It is the correct answer right now. And so ultimately what you'll get is that you get better engineering and better models, and this is going to bring you up on this ladder. But taking a look at prompt engineering, so if I'm sure you've heard about this, so it's really been about people writing these gigantic prompts and trying to iterate on which words to choose, how to condition a model to follow a specific task. And that I think I kind of blame ChatGPT a lot for this, because the models we got in the start when ChatGPT was released were very heavily tuned for chat. So they wouldn't just not shut up and do the thing you wanted them to do, because they've been trained on that. So I kind of wish we had stuck with instruct models, which were popular before. So these models were really made for just doing what you asked them to do. But then the whole field went to chat models, and even the open source world followed chat models by fine-tuning on GPT-4 output. So you got all these models that were always trying to talk to you. You would ask them JSON, and they would say, "Hey, sure, here's the JSON." But then you have to parse this out, and then it's created a bit of a mess in this field. But nowadays, you can get pretty reliable JSON outputs by either asking the right way, models like GPT-4 or Claude or whatever, or you can use something else that's called guided generation that is forcing models to output JSON following certain grammar. So assuming now you can get JSON or YAML or whatever kind of structured output you want for a model, then you can rethink fundamentally how you work from code with language models. you can stop thinking about writing these big prompts and then worrying about parsing and asking the models, okay, you return that field and that field and that field. You can instead just write code like you always have. So the screenshot here is screenshot using the Opper SDK, where I have a function that is solving math problems, and I define it by decorating it with our little decorator coming from the Opper SDK. And what that means is that this transforms this function into an LLM-powered function. So you're basically not implementing it, and the LLM is going to implement it. So I'm writing code. I'm using Pydantic in this case to define my output format. So I want chain of thought, and I want value to answer this question. It's super nice to write code like this because at no point you think about prompts. You're just thinking about really describing what you want, having clear structure. If you want to change it and add an extra field, it's just add an extra line of code. This is super, super powerful. Yeah, like I said before, you can even get models to reliably get you JSON nowadays. So not GPT-4, not closed models, but open source models can do that. And you can ask in your prompt, this is my JSON schema. And it's going to work. It's going to work a lot of the time, almost always. And this JSON schema is your prompt. So you're moving from a prompt where you write a lot of text to describe what you want and give instructions to a place where you define the result you want. And by defining that, you're literally giving the instructions at the same time. And that is a much easier way to work with. So yeah, and by doing that, so we have a blog post that you can check out on our website. You can easily go from 25 to 71% accuracy on the GSM-8K benchmark, which is a math dataset. Okay, next thing to improve accuracy is in-context learning. In-context learning is a fancy word for saying put examples in your prompt, really. I have a graph of context windows over time that I just kind of made up with a bunch of models here. The point is that these context windows are getting bigger and bigger, and you can think of them as the working memory of your computers that used to be a few kilobytes and then megabytes, and now we are at hundreds of gigabytes or more. So this stuff is just gonna get longer and longer. So it means you can put more data in your prompt, which means that you can put a lot of examples in your prompt. You can literally fine-tune a model on the fly to do any task. So this is really the brute force approach. I have a task, I have lots of examples. I'm not even, you might not even bother to put a prompt. Like, you don't need instructions, just put all your examples in there and it's gonna work, and it works really well. It works better and better. So this is really, I think, the future of using language models to do anything. Is okay, if it doesn't work out of the box, I'm just gonna put 1,000 examples there. I can even synthetically generate these examples using a model as well. So this is how you can start working and doing things that are super reliable. But in the meantime, you might want to find the right examples to put in your prompt because you don't want to spend too much money. So again, you could put 1,000 examples, but that's going to be quite expensive and it's slower as well. So there are different techniques that are emerging for finding the right examples. So you have a technique on the left here that's prompt compilation. And there's a framework that's quite popular around this called DSPy. So I don't know if you've heard about it, but it's kind of a brute force way of finding the best examples for a given prompt or task. And so how does that work? You define your success metric. So I don't know, I want to write a good tweet, for example. I'm going to have an LLM measure whether a tweet is good or not. So this is a questionable thing to ask an LLM for because they're not very funny. But so anyway, you have this metric you want to optimize for. I'm going to run a bunch of data through it, get the value. Then I'm going to try different examples. I'm going to get another metric, etc., etc. And you can kind of brute force your way into finding the best combination of examples to put in a prompt. And so this is what DSPy does. It has other optimization methods, but at the core of it, it's really about trying combinations of examples and see which ones perform the best on a given evaluation data set you have. And that yields very big improvements for most tasks, because writing examples by hand is very hard, but it's also not really the way like the handwritten examples are not necessarily the ones that work the best with a language model. So using a model to generate examples often performs better because the wording it's using, like it just works a bit better. So don't spend too much time running manual examples and instead try to leverage synthetic data generation. Another method for getting the right examples, which I think is a bit more oriented towards like production scenarios or like real life scenarios where you don't have these clear data sets for evaluating, is something we do in Opper, and it's called few-shot retrieval. So, okay, let me try to explain. So you have a chatbot dealing with customers, for example, and you get one time, I don't know, an angry customer wants a refund. And then your chatbot handles the situation, and you thought, okay, it did it well, right? And it had a few steps to follow. What if you could kind of basically take this trace that you've seen and say, okay, this was good. I would like it to behave like this in the future. Well, what you can do is that you can save these outputs or these input-output pairs and save them as examples for future reference. And the next time there's an angry customer coming, you can retrieve the examples that are relevant to this use case from a vector database or something like that, and put them in your prompt. And that's going to steer the model a lot in the right direction. This is super powerful when you have use cases where you can have a lot of different natural language inputs. Let's say you want to do text to SQL, and you have queries that ask something about, how many users did connect in 2024 and this month, etc. And you've handled this type of query successfully in the past. If you put an example that's almost the answer, basically, in your prompt, then your model is very likely to succeed, much more than if you would leave it, 0 shots. So that works really well. There's a blog post on our website about this as well, which is interesting, I think. Yeah, so this is an example of a prompt that we send to GPT-4 on the GSM 8K benchmark using examples. So this is pretty far from the type of prompt that people were writing a year ago. So as you can see, we don't have a lot of instructions. The instructions are literally solves math problems, but that's not the focus here. The focus is really putting examples of what you want to do. I think it's kind of working with humans as well. You can explain to them a task forever, or you can just show them how to do it, and it's going to work a bit better. This is very similar. So don't write prompts. Like don't start writing, novels to your language model to do this, and okay, don't do that. Find good examples of when you think it really shows the behavior you want. It's much more scalable to do that. And so in this case, we take this math data set, and by adding examples, we gain almost 10% accuracy. So these techniques really work, and they often work so well that you don't need models like GPT-4. A lot of people are using expensive models because they don't know how to squeeze the performance out of the cheaper ones, but they are not. They're still valuable. All right. If you build production or complex, I guess, applications with AI, one thing you're going to quickly realize is that you have no idea what's going on. If you build a pipeline with more than, I don't know, 2 steps, and you have a function doing something with an LLM, and then you pass that output to an LLM and again, it becomes very quickly impossible to understand where we are and why the current state looks like that. And you don't even know, I think it goes deeper, you don't even know what these intermediate steps should be doing. Like, you don't know what is the optimal path anymore. Because you might have designed it yourself and you've written but it's very likely that there's another path that is kind of cleaner and simpler, that you have with your human brain is, you're not thinking about the right thing for the model. So I think the first step towards understanding this is just tracing, and so it's not a new thing. It's not an LLM thing. It's been in the observability world for a long time. But I think the AI engineering world is where really now it's super obvious that, okay, you must really have tracing. Otherwise, you will never debug your programs and understand where you are. So this is a screenshot from Opper, where I have a little agent trying to do some bug fixing. And I can see on the left the different spans, so the different steps of this bug fixing process. And this is a small trace. I have some that are much longer, and I was very thankful that I had tracing in this instance to understand where I was in the program. So this is really engineering to try to improve accuracy of models and get you to a better state to run different tasks. But I think you don't need agents. If you want to build an agent, you probably don't need an agent. Agents are really, they are the ultimate paradigm where you have a language model or whatever model, and you have a bunch of tools and you just let them loose. You're like, okay, you can do whatever you want. This is kind of an ambitious thing to do, even with a human. If you would hire someone at work and you just let them loose without onboarding them, they're gonna do the wrong thing for sure. And I think it's the same for agents, at least right now. Ultimately, they'll figure everything out and they'll be superhuman, but it's not really how it is right now. So let's look at a concrete example of a bug fixing agent. So let's assume I give these tools to my agent. I give the ability to run code, to write code, to search the docs, to read files, to create files, to search, etc. A common problem with agents right now is that they're going to get stuck in the details. They might be stuck in a reasoning loop. This is something I've seen a lot, where they start on a trajectory that looks reasonable. So that they would start a bit like a human. Okay, I'm going to search this and that. And then they kind of quickly start focusing on a very tiny piece of detail, and they might write some code and run it, and then it doesn't work, and they try to fix it, and then it doesn't work, and they try to fix it, and they get stuck on this, and they never exit this reasoning loop. So it's a very common mistake for agents, and it's because you don't really guide them. You're just giving them free access to all the things, and then they're gonna be a bit doing all the things. So instead, what I think you should be doing, what you should really try to do, is something some people call flow engineering now. I think it's it's just buzzwordy term for software engineering. Try to think about your problem, and it's very unlikely that you don't know how to solve the problem. So if you want to fix a bug, how do you do it as a human? You start by trying to reproduce it, for example, right? Or you start by doing an investigation, and then you think about editing code. So why don't you encode that into your flow, rather than giving the agent like complete free will over all the things it can do? And instead, you write some code to say, okay, my first step is I'm going to try to reproduce it. So I can have a little agent there that's only supposed to reproduce the code, and it's not going to try to do all the things at once. Just reproduce. Okay, now I have reproduced it. I can try to write a little, like a nice description for the next agent in line to help it get a better start to fix the code, etc., etc. And the screenshot I have here is from a paper from Alpha Codium, where they are working on some code generation tasks, and they have this flow that's very far from an agent just doing whatever it wants. They really have hard-coded things where you have this problem, you have to reflect on it, then you need to look at tests and try to reason about them, then you generate some solutions, then you rank them, then you generate tests, etc., etc. So this is very different than just opening up the doors to everything. You really want to limit your solution space as much as possible. So you try to write code. Basically, you don't want to be lazy and just give the agent access to everything. We're not there yet, mostly. So try to really have agents that can do whatever they want as a last resort, and instead try to write flows in code. Another example is a nice little data set called Hotpot QA that you have maybe heard of. It's a data set of questions for Wikipedia, but those cannot be answered in one go. They always require 2 different steps to be answered. So you might have to read 2 different articles and then compare the results, or you have to first read an article and then from there find the next question the next article you want to check out. Okay. So it's a nice data set because it's a data set for agentic workflow where you have to do multiple steps. So you could create an agent like this that says, okay, you have this question, you have access to Wikipedia, you need to answer, go. Right? That's the lazy approach. But you could also write a program that knows more about the problem. So in this case, I know that for this data set, I need to ask 2 different questions to Wikipedia. I know that, so I can encode that. And I know that I need to generate these 2 queries, and then I will generate my answer. So I've gone from this open-ended, you have a bunch of tools do something, to a program where I can loop and I say, okay, you have 2 steps where you generate a query, and then you search that query in Wikipedia, and then I build my final context with these results, and then I generate the answer. This is much, much easier to reason about. It's much easier to read as a developer, and it's much easier to debug and to optimize because it's predictable. Like you don't need to wonder anymore. Okay, where are we now? It's very obvious. It's just you can step through it in code even. And it's going to perform much better ultimately. So really try to write as much code as you want, try to do engineering, software engineering, and use AI only when you need to, and don't just throw everything at it. Okay, but what if you really, really need an agent? Okay, sometimes you really need an agent. That's true. So a few patterns. So React. So this is the pattern that that feels very, I guess, the most obvious to use is you give an agent a bunch of tools, you give them the state of their environment, and then you ask them to think. So you just let them, write a little bit about the current state, and then they decide on an action. You execute the action, and then you give them the feedback from the environment. So if you're doing code generation, for example, it could be whether it compiled or not, or the tests are passing or not, or whatever. And then you just you continue this loop, right? So this is the prettiest or simplest pattern, but it's also the one that performs the worst because it's too simple and it creates these reasoning loops. Like I said before, agents get all over the place and they kind of forgot the point. It's very hard. Then you have reflection. So it's a screenshot from my bug fixing agent here, where essentially this agent has this simple React pattern, but for every action we want to take, we have an evaluation function here that's going to take the action and the problem we're trying to solve, and that's going to judge whether we're on the right track or not. So the idea is to have this sort of external viewpoint on everything we're doing and be able to say, hey, we are completely off track, stop right now. And that works really well for improving performance. Then you have planning. So like I said before, models really suck at planning, and the patterns we use, like React, really are bad at planning because we literally don't have planning. We're just asking step by step, what's the next action? And this is not how you should behave as a human, I think. Like if this is how you work, you're not going to go very far. You should have some kind of background plan. You should kind of know where you're going. So you can ask models explicitly to define plans. On the screenshot here, you see that we have a planning function in this agent that's trying to answer questions from GitHub. So my user query here is, okay, identify a repository offered by the person who wrote the last commit in the API repo in the Opper AI organization. So this is a 2-step thing. You first need to find the last commit in our API repository, and then you need to go look at the person that made that commit and find their repositories. So we ask the model to plan, and it outputs 2 different API paths we need to call. Okay, first, use the commits endpoint to get the last commit, and then call the repos of this user. So now we have a plan, and we can run through it. This performs also a lot better when you can plan ahead, even with an LLM. Oh, I had this arrows, right. Then the final pattern that I think is the future, and that's the one that's going to make this field really explode and a lot of things starting to work, is to use search. So if we take a step back here, where every time you ask a model, it's going to take basically a different path on a tree of solutions in the solution space, right? So it's not random, but it's not excellent either. So what if we just kind of brute force our way to find the right solution and ask the models to generate different solutions, et cetera, et cetera. So there are a bit simple methods for doing this, like tree of thoughts, where you literally kind of try a few different options. You ask models to generate a few different solutions. But there are methods that are much more robust and proven, like Monte Carlo tree search, which has been used in programs like AlphaGo, where you are following an algorithm for deciding which part of the solution space to look at. So you have a tree of solutions, and then at every iteration, you ask an LLM to find about whether the solution you're looking at is promising or not, and give it a score. And then based on that, you have a formula. It's called like upper confidence tree or something like that, where you decide the next branch to look at. And I think lots of companies are working on that now. And for tasks like code generation, it's very, very promising. But obviously, as you can see here, it's going to be more expensive, potentially slower, because you have to call a lot of do a lot of API calls. All right, so wrapping up. Okay, so I think agents are coming because of a few things, and I think the main thing is that the entire field working in AI, from proper ML research to observability, is learning and maturing all the time, and basically all these parts of the stack are helping to get 1% accuracy benefits, and all these things are stacking on top of each other. Base models are getting better. GPT 4.0 is better than GPT 4, and GPT 4 point something or 5 would be better. That's kind of a given. Then on top of that, you have data sets. And by that, I mean that, like I said before, these models have been heavily trained for chat, but now the companies building them are starting to turn towards agentic workflows. So they're going to build data sets of agentic workflows and fine-tune their models for agentic workflows. And they're going to work a lot better when they do that. It's kind of a miracle that we have agents working today without any training data doing this sort of agentic pattern. I don't work at OpenAI, but I really think this has not been the focus of almost anyone until a few months ago. So it's pretty incredible that it has kind of worked. But once you start training these models on this task, they're going to work a lot better, because deep learning is literally just fitting a curve on a bunch of points. So now that we have the right points, we're going to fit them even better. Then on top of that, we are much better at writing prompts, or basically not writing them by giving lots of examples. We have longer context windows. And then on top of that, you have all these orchestration libraries, or like these tree search methods. And even on the top level, the field is starting to understand that you need to test things and write evaluations and compare. So we are really close to agents that really work, I think. And so if you want to build something, I think your goal should be to build a feedback loop so you can measure that it works and improve, etc., and so on and so forth. You should start with the best model, and you probably should be building for the next model that's going to come in a few months. Just like people writing video games, they write video games for the next GPUs or the next console generation, right? They don't have the hardware ready yet, but they know it's coming, so they're anticipating that. So if you have ambition, you should really be building for the next generation of models that are going to be better and faster. Don't write too many prompts. Write code instead. Focus on writing code, doing engineering. Don't use agents if you can. So prefer to have these sort of guided flows where you decide the tasks manually, like you think through them, and you give the agents really very strong guardrails so that they cannot go all over the place. Save working examples to add to your prompts. So really observe, take the best examples, generate examples, add them to your prompts, evaluate, and profit from this feedback loop. Thank you.
Thank you, Alex, for a very clear presentation. A lot of interesting stuff there. So we have about 13 minutes for questions. So please use the hand icon, the raise hand icon in the interface if you want to ask questions. And while we wait for questions, I can just say some things. I mean, it's super interesting. I think it would be very fun to have like a debate between you and some of the people who are building these agent systems in Stockholm, like Lovable, for instance, or who have been building on this GPT engineer. I'm sure it would be a lively debate. But I have to say, I've also had a similar experience with trying to develop software with those frameworks, because you kind of still need to know what you're doing to be able to fix the errors that are introduced. See any questions? Okay, but then I think it's like interesting with this kind of programming with docstrings that you are using here. That you have a function, and then you just have a docstring or a comment that describes what it should do, and then it just does it. I haven't really come across it before, except I also saw it in DSPy, which you also mentioned, that the doc string is like part of the logic. So is this a thing that people do, or did you kind of come up with it?
So I did not come up with it. The first time I saw it was a bit more than a year ago. There's a library called Marvin, so Marvin.ai, I think. They were the first ones who released something like this. But when they released it, I think it was almost like a joke. You know, like this is the future of programming. And I read this and I was mind blown, and I thought, okay, it's kind of a joke, but it's also it's crazy. Like it's so different than what we've known. It's like a bit mind bending. But it turns out that I think this is the way for Python, at least, when you can decorate things and do some magic. Other languages are not like that. But in Python, it really makes things very clear about what you're doing. You're calling a function, so you're treating the LLM like an API. You're not really treating like anything special. And it's forcing you to write docs for your code at the same time, because the docs are the implementation guide. So it's pretty natural to work with this. But yeah, again, it's not as easy in other languages, not as pretty.
Yeah. Okay, we have a question from Rickard.
Yeah, actually, it's not Rickard. We are several people here in the same room. So Lumi is my name. And I have to say that it was very interesting, but I missed the beginning of your presentation. So you'll have to excuse me if you already said these things that I'm going to ask now about. But it's, from my perspective, I'm thinking, like, if you take a step back, we talk a lot about the AGI now, like one model that rules them all, that can be used for a wide range of tasks. So one goes from these specialized models when you have hundreds of models for specific tasks. And if I understand correctly, what you're saying for agents is more that you're saying that you should have quite specific agents for specific tasks. So that kind of increases the complexity and goes against the AGI idea. So I wonder, is this like, first, what are your thoughts about this, and whether you think this, like having this very specific agents, it's something that just works now, but probably we're going to go from this, or what are your thoughts about it?
Yeah, I think a lot of the work we're doing now is very much trying to make a technology that does not work, LLMs, to try to make it work as much as possible. Like LLMs are really just, they're a promise of the future where these things are going to be amazing. But for now, they are not. If you really try to get work done with them, you know, like ship a product that works 100% of the time is a very hard task. And the existing LLMs cannot do it unless it's very simple. So we're throwing a lot of engineering at it by trying to constrain and have a guardrails and basically hard code the solution as much as we can. But as the models get better and better, it's very questionable whether any of this will be left. So the way I'm trying to see this, to not think it's useless, because that would be kind of cynical and sad if you're just like, we can just throw all of this away, is that models will get better, but they're also bigger and more expensive. So there's going to be a track for optimizing things for quite some time. So running things on smaller models faster. And this is when this type of engineering will still be relevant for quite some time.
Right. Thank you.
Yeah, so I think AGI does not exist, as in, like, nobody can define what it is. So I believe the systems are going to be incredible and superhuman. So I really believe in that. But I think the AGI like focus is a bit is a bit irrelevant in some ways. Like you know, the LLMs, they're good at what we train them at doing, and the current ones, they are good at everything because we literally train them to do everything. But they're not good at doing agentic stuff because we don't have a lot of agentic data sets yet. And then we're going to train them on those, and they're going to get better. But it's also possible that there will be new architectures coming out that are doing something more than just next token prediction, the way we do it. But I mean, I don't want to speculate because so far just scaling them has been incredibly powerful. So maybe it's just going to work this way forever. But when you build with this stuff for a lot of time, you see how often it just fails on very basic things.
Right. Thank you.
Yeah, Olivier.
Hi. Yeah, super interesting. I was wondering if do you think that agent can organize themselves? So can you the planning that you have to do by hand, can it be done by also an LLM or an agent, and can this be stacked like that to have like a structure, like on a company, like a manager and several hierarchy levels like this? Is that?
Yeah.
possible?
So there are some frameworks doing this now. There's like AutoGen or Crew AI, which are very much around people, like trying to organize agents that are akin to people. I personally don't like too much not everything needs to be chat in my mind. I think more, I'm a nerd, so like program, like write code, do this A to B, etc. But I do think ultimately these structures are going to work very well. I think there's a paper that came out this month about establishing state-of-the-art like medicine question answering by simulating an entire hospital, having different doctors and stuff looking at the cases. So this is going to work well. And when it comes to planning, it's definitely much better to generate a plan beforehand, asking an LLM to generate a plan. And there are techniques, so you can generate, it doesn't have to be like sequential plan. It can be a directed acyclic graph where you have, this group and this group, and that works better. But like I said, I think the models are not excellent at it yet because they simply have not been trained to do it. But they are going to be, and then they're going to be super good. So that's kind of the way I see the future for us now. Even if we don't have a new architecture, it's just we're going to brute force our way to AGI by just training on literally all the things that we could ever think of.
Thank you.
Yes, I was also wondering about similarities and differences to DSPy, and you did mention that framework in the presentation, but I've been like playing around with it for the past weeks and think it's pretty nice, and there are some similarities, but maybe also, yeah. What would you say are like the main differences?
I think Opper is much more ambitious than DSPy is a framework for having a program that you define and then optimizing it, and so Opper is an entire platform for getting access to models, to indexes, to ingesting data. So it's much bigger scope. But there's a part of Opera that's about optimization, and in that sense, we want to do things like DSPy or better. Right now, we have one technique, which is this few-shot retrieval setting, where we can save examples and retrieve them later for adding them to the prompt. But I want to work more in the direction of compilation as well, and doing things similarly to DSPy. I like DSPy, but honestly, I think it's a very steep learning curve for people. It's super hard to rewire your brain around this. I think when you start with DSPy, I think part of it is because the documentation is weird and they make things sound complex. So that's my gripe with academic stuff often, is that they make things sound fancy when it's not. But it's hard to get over this barrier. And the dream for a product like Opper is that you would write your code, so really write code as you used to, and then it would kind of just work. So by doing things similarly to DSPy or different methods. So there's definitely part of the product that's going to be very similar.
Yeah, and I really like these structured output formats and so on that exist in both frameworks. It's a good practice to start with. But yeah, definitely I want to dive a bit more into Opper as well and see what happens. Do we have any more questions from the audience? Okay, well, yeah, we have one last question. EP, go for it.
Hey, Mikael, tack. Alexandre, great talk. But I was really curious about your thoughts on like you talked about compounding errors. Do you see any risk for like compounding bias? Because as you say, like we need to train on everything. What if we haven't seen everything? Or yeah, if you could elaborate a bit on some of that.
Yeah, so I mean, about bias, do you mean like in terms of safety and what the programs are, like the values and this sort of stuff, or?
Maybe less like ethical stuff, but more so like everything is in Python here, today, here and now. And I think humans are quite, you know, if it's not broke, don't fix it. So is it going to cause a slowdown in certain areas of innovation because, well, the model's writing all the Python, so we just stick to Python? Or
I think we're seeing this already a little bit. It's definitely something I think of when I write code. Is okay, is Cursor? So Cursor is the IDE I use that's powered by LLMs. Like, so is my IDE gonna be good at this? Because the work for me has shifted a lot from writing code to instructing a model to write code while I think about the next step. And so you want this model to have been trained on what you see. So I think this is definitely true that right now you kind of don't want to create a new programming language because no model is going to know about it and nobody's going to want to write it, right? Why would you do that? So I think it's a very valid point. And I guess there might be some much deeper effects that I have not even thought about, like more that go beyond technology, that I have not thought about at all, but it's definitely true, I think.
All right. Thanks a lot. Yeah, we can quickly mention that next week's session will be with Athir Ghatami. I hope. I'll try to get it confirmed today, but he will talk about his AI podcast. So that should be interesting. But yeah, thanks a lot, Opper guys and Alex. Super interesting. Have a nice Friday and a nice weekend.
Thank you.